So today, we're going to dive into a really fascinating project called IVBSIM Plus. It's basically a virtual lab that's designed to make some seriously complex, hands-on training accessible to pretty much everyone, everywhere. Let's see how they're pulling it off.
Okay, so let's start with the big problem they're trying to solve. Imagine you're learning a technical trade. How in the world do you get hands-on experience? I mean, the real machinery costs a fortune, it can be dangerous, and you're definitely not fitting one in every classroom. It's a huge hurdle, right?
And that, right there, is where the IVBSIM Plus project comes into play. It's their innovative answer to that exact problem, and it's looking to completely reshape how we think about hands-on technical education.
And when you look at the vision, you realize this is a huge deal. This isn't just some small app. It's a massive international project with countries from all over Europe collaborating. The main goal? To build a simulator for industrial electronics that's completely open source. That means the code is public, so anyone can see it, use it, and even help improve it. It's also AI supported, which could mean all sorts of cool things, maybe smart tutoring or simulating really complex system failures for students to figure out. The bottom line is to make this high-level training free and available to anyone with a computer.
But how do you even start building something that complicated? A whole virtual world? Well, like any big journey, it starts with a single step. For IVBSIM Plus, that first step and the language at the very heart of the project is Python.
So what is Python exactly? Well, it's a programming language that has become an absolute powerhouse in the tech world, especially for things like AI and data science. The reason they call it a high-level language is that it's designed to be super readable, almost like plain English. And that simplicity, that's what makes it so perfect for a big, collaborative, educational project like this one. And why is it such a great starting point? Well, honestly, because it's famous for being easy to learn. The way you write it is just clean and simple. You don't have to worry about a bunch of confusing symbols like semicolons at the end of every line. Plus, as you can see, the same code just works whether you're on a Windows PC, a Mac, or a Linux machine. It's all about getting you from your idea to a working program as fast as possible. In fact, it's so fast that you can get your first program running in what feels like no time at all, almost like magic. We're talking less than a minute from starting the download to actually seeing a result. Let's see how that works. The setup is just beautifully simple. You go to the official website, python.org, and download it. You run the installer, and now this is the one really important pro tip. Make sure you check the little box that says Add to Path. All that does is tell your computer where to find Python, so you can run it from anywhere. And that's it. You're ready to start coding. And here it is, the magic spell. It's just one single line of code. All we're doing is telling the computer to print whatever text we put inside the quotation marks. That is your entire first program. And boom! The second you run that line, this text pops up on your screen. You gave the computer an instruction, and it did exactly what you said. That instant feedback, that little aha moment, that's the core of what makes programming so cool. And it's the very first step toward building something much, much bigger. Okay, so you've made your first command work. Awesome. But how do we get from printing a single line of text to building an entire virtual simulator? Well, it all comes down to combining just a few simple but really powerful building blocks. The very first building block is something called a variable. The easiest way to think about it is like a labeled box or a digital container where you can store a piece of information. So here, we've made a box called exam_score, and we've put the number 85 inside it. From now on, anytime we need that number, we can just refer to the box. Simple as that. Next up, we have operators. These are basically the tools you use to actually do things with the information in your variables. And for the most part, they're the same math symbols you've known forever. Plus, minus, multiply, divide. This is how you tell your program to do the work, like calculating an average score or simulating the electrical resistance in a virtual circuit. Now this next one is one of the most powerful ideas in all of programming, loops. Think about it. How do you get a computer to do the same thing 100 times? You don't write the code 100 times, you just use a loop. A for loop is perfect when you know exactly how many times you want to repeat something, like saying, hey, run this test 10 times. A while loop is for when you want to keep going until something changes, like keep this virtual motor running as long as the user hasn't pressed the stop button. So let's recap. We've got containers for our data, tools to do things with that data, and a way to repeat those actions over and over. With just those fundamental ideas, we have everything we need to see how a few simple lines of code can grow into something truly incredible. So here's the crucial thing to realize. Everything we've talked about, your whole programming toolkit, it really just boils down to these three concepts.
You store information in variables, you act on it with operators, and you repeat those actions with loops. That's pretty much it.
And here's the mind-blowing part. Just by combining those three simple ideas, variables, operators, and loops, in clever ways, you can build something as complex and as powerful as the Ivy Epson Plus industrial simulator. Every single button you could click, every dial you might turn, every circuit that gets simulated, it's all built from these same fundamental pieces.
But this project's vision is so much bigger than just being a cool teaching tool. Because it's open source, its impact goes way beyond the classroom and points to the future of how we can build things together.
I absolutely love this quote from the project's own documentation because it just perfectly captures their whole philosophy. By making the code open for everyone to see, they're not just teaching students how to use a simulator, they're inviting them to improve it, to change it, and to become creators and developers themselves.
And that really leaves us with a final, powerful question to think about. What happens when you tear down the barriers of cost and physical access? And what happens when you empower people to not just consume information, but to actually create with it? What becomes possible when learning truly has no limits?